Okay, problem number one from this Friday's quiz. Calculate the volume in quarts. Notice I'm throwing an English unit at you. Calculate the volume in quarts occupied by 4.94 times 10 to the fifth moles of titanium tetrachloride, or titanium 4 chloride. Now, I gave you several pieces of information. One of the most critical is I give you the density of titanium tetrachloride as 1.73 grams per milliliter. Almost forgot the per milliliter part. We are given moles. Moles is a unit of mass. And we're being asked for quarts, which is a unit of volume. So inherently, we need the density because that is our relationship between mass and volume. So when you're looking at a problem, notice the information that's given to you. I also gave you conversions between gallons and liters and quarts and gallons and so forth, and we'll use those. But in this case, that critical piece of information is the density. Dimensional analysis, factor label, whatever you want to call it. So we have this piece of information given to us. 4.94 times 10 to the fifth moles of titanium tetrachloride. It's not guesswork. We know our answer should be in the unit of quarts. So we have what we're given, we have the unit of what we want. So now we have to start grinding through the problem. Moles of titanium chloride to a volume. Well, before we can use density, moles, density is in units of grams. So we're going to need the molar mass. And I've already gone ahead and calculated it, but look up titanium on the periodic table. Look up chlorine. So there's 1 titanium and 4 chlorines. And that's going to give us this relationship. So 1 mole of titanium tetrachloride is 189.68 grams of titanium tetrachloride. Okay? Moles cancel. Now we're in grams. Mass, we want volume. Again, kind of beating that to death, but it's very important to recognize that now we use the density. 1.73 grams of titanium tetrachloride is equivalent to 1 milliliter of titanium tetrachloride. I'm kind of writing it underneath just to kind of keep this a little bit more compact so I don't go too far. So now, grams of titanium tetrachloride have canceled. Now we have a unit of volume, milliliters, but we want quarts. So we're in a very good position now. We have a metric unit, we want the English unit, just because of how this problem was written. I give you the relationship that 1 gallon is equal to 3.7854 liters. That's milliliters. I expect you to know the metric system. So, and it never hurts to write it off to the side before you use it. So 1,000 milliliters is equal to 1 liter. So, 1,000 milliliters is 1 liter. Again, titanium tetrachloride. Always want to put that in there. Milliliters cancel. Now we're in liters. Now we can use that relationship, again, that you were given, that 3.7854 liters so 3.7854, plenty of sig figs, liters of titanium tetrachloride is equivalent to 1 gallon of titanium tetrachloride. Liters cancel, we're in gallons, and we're so close. The last relationship you need is gallons to quarts, and you're given that 1 gallon is 4 quarts. Again, just go ahead and put in the titanium tetrachloride. So gallons cancel. Quarts. We are now in quarts of titanium tetrachloride. That is the unit we want. So now pick up your calculator and do the math. And you should get, right here, 5.72 times 10 to the 4th quarts. Just to save a little bit of space, I went ahead and converted this directly into scientific notation. When you did this in your calculator, you would have gotten 57,233.5. Based on three significant figures, our answer should have 3 significant figures. So 5.72 times 10 to the 4th quarts of titanium tetrachloride. We took 1, 2, 3, 4, 5 steps to get to our final answer. Again, dimensional analysis is an incredibly useful problem-solving method when you understand it. If you don't understand it, it's gonna basically be like being in quicksand, because going from here to there, as you can see, 5 steps. There's no shortcuts that you're going to find that are going to work.